Hi, everybody. I'm Karen Field. I'm content director for Fierce Electronics, and I'm sitting down today with Jim Smith, CEO of Klarrio US and co-founder of the company, which is a cloud native services integrator specializing in cloud-based streaming solutions. Hi, Jim.
Hi, how are you, Karen?
I'm good. I'm good. Glad to be talking to you today. Can you
Yeah,
tell
thank
us a
you.
little bit? Yep. Can you tell us a little bit about what is a cloud-based streaming solution?
That's a great question. If we go back in time, a lot of clients were doing batch-oriented jobs, and actually, they're still doing those today. The challenge with those is the data that's coming in is lagging. Actually, what's occurring in the business or what's occurring in an IoT system. So essentially, what we do is we build low latency systems to ingest massive amounts of data, regardless of where it's coming from and how it's coming at us. And we build those systems predominantly in a cloud-based architecture. So those are not servers in your data center. Those are servers that are, say, in Amazon or AWS or in Azure. And we are cloud agnostic, so it doesn't matter where we actually put our technology. We'll put it on whatever cloud a customer wants to utilize.
Right. I know that Clario specializes particularly in projects with complex integration requirements and massive amounts of data, of bi-directional data flow. Could you talk a little bit about just some typical examples of IoT space projects you've worked on, and what are the characteristics that make them particularly challenging?
Yeah, it's the variety of the data that we have to deal with and the amount of data. A lot of IoT systems are fairly small. Even to us, a thousand sensors on a network is a very small system. We've had people call us and say, we have 100 sensors and we'd like to hook them up. We can tell you how to do that. It's actually very easy. Where it gets complicated is when you get up in the six figures or you get millions or half a million devices. And so those devices that are out in the field are very chatty. They send data at a very high frequency, and that causes a number of challenges. It causes challenges on data ingest, how to actually bring that data in, how to make sense of it, and how to get it across a platform in a really low latency fashion. So we solve all those problems. The biggest challenge that we solve is called fan in and fan out, where we have fan in is where we bring massive amount of data in a really short time frame. Fan out is when we go the other direction, right? When we need to communicate out to these devices in the field, and we need to do that quickly. So you could imagine an alerting system to emergency responders where you need to hit millions of them or hundreds of thousands of them in a really short time frame. And those are some of the use cases that we actually work on.
Wow. I mean, talk about challenges. I think you you really, you know, it really are up against a number of them. I'd like to focus on one particular project, the Data Services Hub that you launched in partnership with the Dutch telco giant KPN and the Dutch government. And I'm wondering if you can just describe it at kind of a high level, what that project involved.
Yeah, I can certainly do that. That was the Dutch government, as you mentioned, and KPN, who's essentially Dutch Telecom, won a bid for talking traffic. So the government funded what I'm going to call a Smarter Cities initiative or Smarter Government initiative with this talking traffic consortium. The problem is they didn't have technology that really stood up to the requirements. And what we're talking about is traffic flow. So the Dutch government wanted to really optimize traffic flow as opposed to building more freeways across their country. And so what the challenge was is to take all this data that's coming in off the highways, and there's loops every few miles in every lane of the major freeways and major thoroughfares throughout the country in the Netherlands. And so essentially what we did is built a platform that allows all that data in massive forms to flow into the system. And then in a low latency fashion, we move it across the platform. What does that mean, move it across the platform? Essentially, we will make it available to partners or competitors. So you could imagine on this traffic platform, you've got different vendors that have competing requirements. Maybe they want to provide a traffic solution to say, first responders, right? And we have a lot of those type scenarios where they'd like to clear a priority lane. They understand there's traffic. They know they're going from point A to point B. There's a busy intersection. So we could actually, if we know their route, we could actually turn a light green, clear a lane, and then let that first responder know that this lane is open. So they need to move over to the right. They can go right through that intersection. We'll turn the lights green in their direction, only in that lane, and let them proceed in a much quicker fashion than they normally could.
Wow, that's so powerful. Can you talk about the sensors? I mean, what type are they? Where are they located? What type of information are they collecting?
Yeah, it's a variety, and from our standpoint, it doesn't matter what the payload. We talk about messages coming in and messages going out. It doesn't really matter to us as the technology provider what that payload is. In the case of talking traffic, it's loops in the road. So we get impressions. We understand how many cars have gone over this loop. We understand the length of the vehicle. Potentially, if the sensor was capable, we would even understand the weight. So we could tell if it's a truck versus a car pretty easily. And those have different profiles and different potential solutions for how you optimize traffic flow. And so we get a variety of data. We've even had bridge data coming in, is a bridge open or closed? Because one of the big challenges in the Netherlands is they have a lot of canals and they have thousands and thousands of bridges. So what I understood in working with some of these entities is that a third of the time they ask for the bridge to go up, it doesn't go up. So we have to find mechanisms to actually monitor and do predictive maintenance. So again, feeding in a variety of data sources. In the case of a bridge opening, it would be current or voltage to see how is that bridge actually performing. And then in a timely fashion, we send a crew out to actually repair that bridge or that motor before it actually fails, and they call for an open or a close, and it doesn't actually do what we asked it to do.
I would imagine that there were lots of different considerations and requirements. Even in something like data latency, it might not be as important for one thing to be communicated right away as something else. But I'm wondering if you could talk a little bit about, sort of what were the requirements that were handed off to you in terms of building your infrastructure.
Yeah, they evolve just like every project. The initial one was multi-tenancy, so we needed a secure mechanism. And again, security is top of mind at Klarrio. We always build solutions with security first. So security was not bolted on later; it was actually built into the system. Multi-tenancy is another requirement that's absolutely critical. We have a common platform, but that doesn't mean that everybody has access to the same data at the same time. So we actually allow the data provider to curate who has access to what piece of information. The interesting thing about that is we have a lot of data sources coming in. They're secured. Sometimes they're very difficult for us even to see, if at all. And then the data provider can select who has access to those. Where does that become important? Here in North Carolina, we have hurricanes. You could imagine if we have a hurricane hitting the coast, what's going to impact cities like Raleigh and Charlotte. So if they have a common system and it's secure and you have a way to curate the data sources, you could quickly see how you could turn on the data for a variety of agencies and give them access to the real-time data, as opposed to going back to, say, spreadsheets or sending documents around where the data is, 2 or 3 days old. And that's the problem with a lot of systems. The latency is so high. We think, well, I'll put the data in today and I'll update it tomorrow. In reality, the situation's evolving and changing over minutes or hours. And you don't have the right data. So we end up with, releasing large bodies of water downstreams, and they have an impact on the coastline.
What tell me a little bit about the communications part of it. You've described this as two-way data communications. Clearly, information is being processed, something is handed
Mhm.
back to the users, if you will. What type of networks are you using to make that happen?
The networks, we're in public clouds for the most part. We can certainly deploy on-prem if needed. You end up with a lot of firewall issues if you're deploying in a data center, where the cloud environments are more open, more configurable, very resilient. They allow the high ingest that we actually need. So running in the cloud environments is top of mind to us. The technology stack is, technologies that you hear about every day. We use streaming systems like Kafka and Pulsar. We use protocols, open protocols like MQTT. The challenge is really about how you secure those. And again, we use containers heavily in the cloud. All of our assets come from code. So if we need to stand up an environment, we have multiple environments standing up at this particular time. What we do is we stand them up from code. We pull everything out of a repository, we build it, and we deploy it all in about 30 minutes. And so we can take a system down, we can bring it back up and have it running in a really short amount of time. But the interesting thing is how we bring the technologies together. People ask us all the time, just give me the list of technologies. I'm really competent and I know how to build things. That's very true. The challenge is to get to the scale we need. Some technologies are really good at handling millions of devices with small messages. Other technologies are not so good at handling that volume of devices, but they're really good at handling massive ingest, so large messages. So what you need to understand is how to actually bring all these technologies together. I know a lot of your subscribers are probably interested in open source. We have over 100 open source projects that we contribute to or we leverage in the projects that we actually build. Open source is very innovative. We've been in open source for many years, all my career, and I've been around for a number of years. We've leveraged open source and contributed into those communities. So in the underpinnings, it's all the common technologies that you see today. It's the Kafkas, it's MQTT, it's Calico. The list is very long of technologies that we leverage.
I wanted to ask you, going back to the latency issue, is certainly sometimes where latency is an issue, people are doing more processing locally, and I'm wondering if that do you get involved in some of that decision making about what I'm going to process locally versus what's happening up in the cloud, or again, is that kind of with the different organizations that you're working with, they're making some of those decisions before you get involved?
It depends. A lot of times, agencies or a customer will actually embark, and again, with a multi-tenant platform, we actually have a variety of customers that are working on this platform, and they're very competent. They understand their domain very well. The problem is they may not understand streaming data. And so, in many cases, and we have a full data science team that focuses on how to build solutions with data that's streaming and continuously coming at you. So, in some cases, we have a customer that can actually build a solution and it actually works very well. In other cases, they get somewhere in the middle and they say, uh-oh, we have a problem. And when they have that problem, then we bring in the data science team or the data engineering team to really help them understand what does it mean when data continues to come at you. How do you make decisions in near real time? Because across the platform, from when we ingest to when we can actually do something with it, is less than 100 milliseconds. And we're not talking about gigabytes of data. We're ingesting petabytes of data. And just to give you context, it's like 11,000 4K movies. So you could stream these movies nonstop for 2.5 years. And that's the data we bring in. We bring in a petabyte a data every 6 months, on the variety of platforms that we have. So it's a lot of data. And then the question is, what do you do with it? How do you make sense of it?
It's just hard to fathom that much data. We've got time for really one more question here, and I wanted to make sure that we talked a little bit about the fascinating work that you've done in the area of elite sports analytics for Olympic teams. And I wonder if you could just briefly touch upon what you've been doing over there.
That's a fun one. Many years ago, back in 2016, seems like a lifetime ago, we helped the women's team pursuit, the USA cycling team, move from really static data sets, really spreadsheets,
Wow.
during their training sessions. And the problem with that is they do so many training runs as they're preparing for an event like the Olympics. If you get the data to them in 3 days, they can't remember what happened during that particular training run. They know maybe, yeah, we had a problem. We didn't hit the times. We missed our switches between leaders. What we did is we really took that data, brought it into a system in real time, and then as they cooled down on the track, we had that data available in really digestible formats at the track site. So they could sit down and understand, like, oh yeah, we know what happened right there, right? And we lost, a fraction of a second. And so they won silver. It was an exciting project. Great to work with the athletes. We've also done Dutch speed skating with our Belgian heritage with the company, and we helped them instrument their track. And speed skating is huge over in the Netherlands. And so they were doing fan engagement, really doing prediction about who was going to actually win the race. But again, it went back to the data in real time and bringing that into a system and making sense of it.
Wow, how powerful. We are about out of time here, Jim, and I wanted to thank you for chatting with me. I know that you will be on the panel coming up later this afternoon, and I look forward to hearing more about your insights and experiences working with IoT and data analytics. Thank you.
Well, Karen, thank you so much for the opportunity. It's been great.